This video will introduce you to making and editing a graph in Microsoft Excel. Here, you will learn to write formulas to take advantage of the power of computers. You will also learn how to use Excel's fill function to increase efficiency when working with data. Finally, you will learn how to make a graph of averages in Excel. This graph will contain error bars, and it will be properly formatted to meet the guidelines for most scientific journals. This video is not exclusive to Excel. Free alternatives to Excel include LibreOffice, which is a cross-platform, fully functional office suite. The spreadsheet program included in LibreOffice, Calc, looks similar to older versions of Microsoft Office. The formulas and techniques illustrated in this video will also work for Calc. However, formatting and editing the graph is slightly different. Let's introduce a problem of the type that you are likely to encounter in a lab-based course. This specific problem has you collect data and plot the means to investigate differences between various groups. You visited several areas of campus and identified 4 pecan trees, which may be different varieties. If all trees are the same variety, then the pecans should be approximately the same size. To test this, you collected 10 ripe pecans from each tree and measured the length in centimeters. You must graph the average length of the pecans for each tree and add standard error bars to illustrate variation within the groups. Based on the problem, the objective is to calculate average length of pecans and the standard error of the length. Then, use these values to make our graph. Knowing our objective, we can now establish a basic approach to guide us in the creation of the graph. Our first step is to enter the data into Excel. After entering the data into Excel, we then calculate the average and standard error. We'll utilize the power of Excel to have it perform the necessary calculations for us. Once we have the data used for the graph, we must then rearrange it into a format that will make graphing easy. A graph is then made. We will proceed to modify it by adding error bars, labeling the axes, and modifying the axis limits if required. Let's briefly talk about graphs. A graph consists of various parts. The largest part is the figure area. This is the box that will contain all elements of the figure, excluding the caption. The plot area contains the data points and/or lines. In some cases, the legend could be placed in the plot area. The final 2 areas within the figure area are for the axes. The x-axis contains the independent variables, or those variables that we, as experimenters, can control. An example of an independent variable is treatment conditions. The y-axis contains the dependent variables, or those variables that we will measure. Lastly, your figure will need a caption. For figures, the caption appears below the figure. When making graphs, we should follow specific rules. First, the data should encompass 2/3 or more of the plot area. We want the coverage to include 2/3 of the x-axis and 2/3 of the y-axis. Second, the axes must be labeled. The reader must be able to interpret and understand the graph without having to read a description of the figure in the caption. Relatedly, and rule number 3, all units must be labeled. If a data point is 50 units up the y-axis, then what does that mean? Is it 50 centimeters, 50 millimeters, or 50 feet? Label the units. Fourth, the caption goes below the figure. This caption should be a concise statement that describes the graph. The function of the caption is to replace the title. Consequently, a title is not required and should not be included in the figure. Fifth and finally, there should be no chart junk in the graph. What is chart junk? It is extraneous material, be it ink, lines, or points, that do not contribute to the message that you are conveying with the figure. As such, you should not have shading in the plot area. A legend is only used when plotting 2 or more groups, and grid lines should almost never be used in a figure. These 3 items are the most common types of chart junk, and they should be removed whenever making figures. Let's return to our example and see how we perform our work in Excel. I will be working in Excel, so feel free to follow along with this video by making the same figure. If you need to pause the video to complete a task, then please do so. This is a basic Excel spreadsheet. Recall that we collected data by measuring pecans from 4 different trees. Now, we must enter the data into Excel. When entering data to prepare for making graphs, each group or tree should have its own column of data. This will make performing the calculations easier and more efficient. The data were previously entered, so feel free to pause this video and enter the values into your Excel workbook. After entering the data, our next task is to calculate the average for each group. We will make use of formulas and let Excel calculate the averages for us. There are several functions that we will use: average, standard deviation, and count. These are built-in functions, and whenever used, Excel will know the correct formula to use. To use the formula, we click on the cell where you want the value to appear and type in the function. In order for Excel to know that you want a calculated value and not just the text, we must type the equal sign before specifying the function. For example, I want the average to appear in the first row under our data. I will label the row by typing average and equal sign into the column just to the left of the first column of data. The equal sign is at the end of our text, so Excel does not recognize the text as a function. In the next cell, we want the average length of the pecans collected from tree A. To have Excel calculate the average, we would type equal average left parenthesis. At this point, the equal sign tells Excel that you want it to use a built-in function. Therefore, as you start to type the function, Excel will list all of the functions beginning with the letter A, the first letter of average. With each letter of average, the list shrinks until 4 average functions remain, one of which is the average that we will use. We finish average with the left parenthesis because we must now tell Excel the data for which it should calculate the average. We do this by selecting the range with the cursor. For pecan tree A, I will place my cursor at the top of the column, left-click and hold, and drag the blinking box around all of the data within the tree A column. When all of the data are selected, I release the left mouse button, type a right parenthesis, and hit enter. The enter finishes the formula, and if everything is entered correctly, then Excel will replace the text that we just entered with the actual calculated average for the pecans collected from tree A. We can repeat the typing and selecting for each column, or we can take advantage of Excel's fill function. The fill function takes a formula within a cell and fills blank cells with the formula and updated references. In this case, we want the average function to fill each of the 3 remaining cells in the average row. To fill the cells with the same formula, we first click on the cell with a formula that will serve as a template. This would be the cell with the average for tree A. Notice the black square in the lower right-hand corner of the cell. This is a fill handle and will be used to fill the function across the column. When you place the cursor over that square, the cursor will change shape. When it does, left-click and hold the button. Drag the cursor to the right, and when the cells in the remaining 3 columns are highlighted, release the left button. You will see that averages now appear for each of the 4 columns. Click on any of the cells with the average. When you do, you will see the formula appear in the formula bar. Notice that the formula is the same, but now the references have been updated so that the averages are the averages for the 10 data points immediately above the cell where we want the average to appear. Now that we have averages, we now move to the next step, calculating standard error for each group. The equation for the standard error is the standard deviation of the data divided by the square root of the sample size. Excel does not have a built-in function for the standard error, so we will write one using the functions that are in Excel. We start with the standard deviation. Like the average, I want all of the standard deviations to appear in a single row immediately below the averages. Furthermore, I will utilize Excel's built-in function for standard deviation to calculate this value for each tree. The function that we will use is stdev.s. This gives us a standard deviation of a sample as specified by the period S after stdev. We write the function as usual, beginning the text with the equal sign. Next, we highlight the data for which we want to calculate the standard deviation. When completed, we close the parenthesis and hit Enter. The standard deviation for tree A has just been calculated. We need the standard deviations for all 4 trees, so now I'll use the fill function again. I left-clicked and held the button when the cursor is over the fill handle. Drag the box down the row and release the button when all 4 columns are selected. With the standard deviation now calculated, we can calculate the sample size n. In this example, we have the same sample size. 10 pecans were measured for each tree. We could type 10 in each of these 4 cells, but there's another method that allows Excel to count the data for us and return the correct number. This is useful whenever sample sizes vary and our data set is large. To calculate sample size, we will use Excel's count function. Like average and standard deviation, I will write the function and fill it across the row. Here is how I do it. Excel allows us to write complex formulas into cells. Furthermore, Excel permits the inclusion of built-in functions in these complex formulas. Here is the formula for the standard error. I will use our 2 calculated values, the standard deviation and sample size, along with a built-in function, the square root, to calculate the standard error. I click on this first cell and type the equal sign. Remember, this tells Excel that we want to write a formula and have the value returned to us within the cell. Now, I click on the cell that has the standard deviation for tree A. Notice that Excel inputs the column letter and row number into the formula. This is Excel's way of telling us that we are using the value found within cell C15. We now type the / for division and type sqrt left parenthesis for the square root. We want to take the square root of the sample size, so click on the cell with the sample size and type the right parenthesis. Like before, Excel inputs a cell reference into the equation. Now that the equation is complete, hit the Enter button and the standard error will now appear in the cell. Use the fill handle to fill the formula across the row. And Bob's your uncle, we now have all of the data required to construct our graph. Making figures in Excel isn't very difficult if the data are properly arranged. It is easiest to reformat our data so that the first column represents the values on the x-axis and the second column represents the values for the y-axis. We then add one more column for the values used to create the error bars, the standard error. You could type the data manually, but why do that when we can copy and paste the values? Here, I've marked a new data area that will serve as my graph data. We need the data for the first column, which are the labels on the x-axis. Our independent variable is tree, so I'll highlight the 4 cells from the data table and copy it. I've become accustomed to using the shortcut Control-C to copy, but you can also right-click and select Copy from the menu that appears. Now that the 4 cells are copied, we want to paste them into a column. If we right-click and select Paste, then Excel will paste the values as they appear. That is, all 4 trees will be pasted in a single row. However, we want the 4 tree labels to appear in one column. Thus, we need to transpose the data before pasting it. To paste them into a column, right-click where you want the labels to appear and select Paste Special. A new window appears that allows you to specify what you want to paste. Of interest are 2 things, values and transpose. For values, we tell Excel that we want to paste the returned values instead of the actual cell contents. When is this used? We use it when we write formulas. We'll see an example shortly. Transpose will flip the data from row to column, or vice versa. For our tree labels, check Transpose and hit OK. As you see, our tree labels now appear in the first column of the graph data. The second column will contain the dependent variable, which is the average pecan size for each tree. Our data actually exists as a row, and to make it appear in a column, we must transpose it. Furthermore, our data were calculated using a formula. If we copy a cell, like so, and paste it into an empty cell, then Excel will paste the formula and update the references. But that's not what we want. We want to paste the actual value and not the formula. As such, select all four averages, copy them, and click on the cell where you want the averages to appear. Right-click and select Paste Special. Like before, check the Transpose option. Additionally, you must now check Values. This tells Excel to paste the value instead of the formula. Click OK, and you will see that averages now appear in the area of our graph data. Copying and pasting the standard error is the same as what was done for the average. I will highlight and copy the cells corresponding to the standard error. I click on the cell where I want it to appear. I then right-click and select Paste Special. I check both Value and Transpose, then I click OK. As you can see, we now have 3 columns of data that will be used to make the figure. Our objective is to make a graph that displays an average for each of the 4 trees. To accomplish this task, we will make a line graph and format it to meet our goals. The advantage of a line graph is that each label on the x-axis will be equidistant to its neighbors. In other words, our trees will be equally spaced on the x-axis. We make this graph by highlighting the independent and dependent variable columns. I do this by clicking on the top left cell, left-clicking and holding the button, drag the highlight box to the bottom right cell of the data, and release the button. With the data highlighted, click on the Insert tab in the ribbon menu. Here, you will specify that we want to insert a line graph. This opens a new menu that allows us to pick from several types of line graphs. We want the graph with each point marked with a dot. More specifically, we will click on the graph for the line with markers. When you click this button, a graph will be made. I can move the figure by left-click and holding when the cursor is on the border of the figure. The new graph connected the points, but we only wanted points to appear on our graph. Why can't we connect the points? We can't use the lines because our independent variables are groups or categories. So let's remove the line. Right-click on the line. In the new menu window, select Format Data Series. In the options on the left, click on Line Color and select No Line. Now click the Close button. The graph is closer to what we want. Now that we have a graph where each point represents an average, our next step is to add the error bars. To do this, click anywhere in the figure so that it is selected. When the figure is selected, the Chart Tools menu will be available in the ribbon. Here, click on Layout to bring up the layout options. You'll notice that there is an Error Bars button available. Left-click on this button and click on More Error Bars Options. We calculated standard error because we want these values to represent the error bars. To specify this, we must click on the Custom Radio button and then on the Specify Value button. As a side note, before clicking on the Specify Value button, make sure that the Format Error Bars window does not cover the graph data. The Specify Value button opens a new window that allows us to tell Excel how far to extend the error bar above the point and how far to extend the error bar below the point. By arranging our graph data prior to making the graph, we can add error bars to all of our points very easily. Click on the icon at the right of the text box. This will allow us to select a range on our spreadsheet. Select all of the text in this box and hit Delete. Now, highlight the standard error column in our graph data. I left-click and hold to select the entire column. The range will be highlighted by a blinking box. The reference to this range will now appear in the text box. We've finished selecting the range for the upper error bar, so click the icon on the right-hand side of the text box. I'll repeat the process for the lower error bar. I click on the icon, highlight and delete the text, select the range, and click the icon. We have now finished specifying our range, so click the OK button to close the Custom Error Bars window. Finally, click the Close button to close the Format Error Bars window. As you can see, our graph now displays average pecan size with error bars. The new graph violates several of our rules, so it must be modified. Our first rule specifies that our graph data should encompass 2/3 or more of the plot area. Clearly, our data points fill less than half of the plot area. To correct this, we will modify the y-axis limits. Based on our average values, we could change our axis to only display values between 2 and 4. To modify the axis, left-click on the y-axis to select it. Then, right-click to open a menu window and click on Format Axis. Under Axis Options, we will specify both the minimum and maximum values to display on the y-axis. For minimum, click on Fixed and change the value to 2. For maximum, click on Fixed and change the value to 4 if it doesn't say so already. Click the Close button and re-inspect the graph. If the axis limits need to be changed again, then continue doing so until the data cover 2/3 or more of the plot area. For this graph, our data cover about 2/3 of the plot area, so I will not change the axis limits. Our second rule requires us to label the axis. Left-click in the figure margin to select it, and show the Chart Tools menu in the ribbon. Under the Layout tab, click on Axis Titles, Primary Horizontal Axis Title, and Title below Axis. In the text box that appears, left-click in the box and type in the axis label. I will use Pecan Tree as my label. The y-axis is added in much the same way. Click on Axis Titles, Primary Vertical Axis Title, and Rotated Title. For this axis label, I used Pecan Size. The third rule of graph making is that all units must be labeled. Inspecting our graph shows that the y-axis is numeric. But what do these numbers mean? Are our averages in feet or centimeters? To specify the units, I will update our axis label to include the measurement units. Click on the axis label. The label is a simple text box, so move the cursor to the end and add the units of measure. Our third rule is now satisfied. The fourth rule requires a caption instead of a title. Let's remove the title. Be sure the figure is selected, and under the Layout tab, click on Chart Title. Click on None to remove the title. What about the caption? In normal situations, you will copy and paste this figure into a Word document. When you do this, you can then add the figure caption below the figure. We will not do that in this video, so we'll ignore the caption and move to the final rule of graph making. Chart junk is problematic because it is a distraction to the reader. In this figure, there are two pieces of chart junk, the grid lines and the legend. To remove the grid lines, click on the figure to select it, look under the Layout tab in the ribbon, and click on Gridlines. Click on Primary Horizontal Gridlines, then click on None. This removes the grid lines. Lastly, let's remove the legend because we are not graphing multiple series or groups in this graph. With the figure selected, click on Legend under the Layouts tab, and click None. We have now made a graph of average pecan size with error bars that represent a standard error, and we properly formatted it to convey as much information about our experiment as possible. Thank you for watching and learning how to use Excel to make a figure of averages.